morning, students. I'm Professor P.P. Durmini from Mechanical Department of AITM Belgavi. I welcome all of you for the today's session. In this session, we are going to continue the failure of materials. In the last session, we had discussed about the basic concept about failure and what is the meaning of fracture. So, before going to the today's session, let us recall what the things we had discussed in the last class. So basically, what is failure? Failure is, we can say, any product or any material. It is not functioning properly, or we can say the material or product. It is getting failure in the middle, or it is not performing the function what we are expecting from that material or any product. That we are going to call it as a failure. I'll repeat, any material, either it may be steel, either it may be aluminum, either it may be a plastic material or a non-metal, any material, it is not performing its function in the middle or after some time. The material is getting failed to perform its function. That we will call it as a failure of a material. So failure, we are going to connect with the fracture. So when any material, either it may be metal or either it may be non-metal, when it gets fractured, then we are going to call it as a failure of the material. So when the material can get failure, there are various possibilities. So the materials will undergo a fracture or a failure. See, in any function or in any applications, we are going to use different kinds of materials or a single material, and that material, it has to encounter or it has to face various kinds of loads. Either it may be a tensile load, or either it may be a compression load, or either it may be a combination of tensile load and compression load. And even it has to face a different environmental conditions, like it may be higher temperature or it may be a lower temperature or it may be higher pressure or lower pressure. So during this scenario, material will behave differently, and there is a possibility or there is a chance of getting a fracture. So that fracture, we are going to call it as a failure of the materials. So to avoid this fracture or a failure of the materials, the precaution we have to take. So that is what we are going to study in this entire chapter, and based on the analysis or when we study deeply, we can able to identify how the failure of metals is going to take place in a different materials and how it can be avoided. So let us go to the definition of fracture. Fracture, we can say, any body or any material when it is under a loading conditions or it is facing some stress inside the material. That material which separates into two parts or more than two parts, that we are going to call it as a fracture. Just see, this is the one material. This is a material, and this material, when it is under tensile load, it is under tensile load. So this material has some capability to sustain the loads. This material, for example, this material is steel and it has some capacity to sustain the load. So after crossing the limit, or we can say yield point of that material, then the metal will get into two parts. The metal will get separate into two parts. So this breaking of the material, we are going to call it as a fracture. Why this material gets fractured? The material get fractured because of due to the overloading or due to the continuous loading, the bondage between the atoms inside the material becomes to lose their energy, or it starts to lose their bonding between the atoms. So due to that, what happens? Atoms, or due to that, what happens? Material becomes weak and finally material gets into different pieces. So that is what we are going to call it as fracture. These fractures are happening because of the load which is acting on the material, or the stress which is inside the material. Due to that, material is getting fractured. So depending upon the type of load, fracture may be termed as tensile load. So when we apply tensile load on the material or any material, when it takes a fracture or when it faces a fracture, that type of fracture we are going to call it as a tensile fracture. And next one is compressive fracture. In compressive fracture, the load will be the load will be a compressive, and due to that, fracture is going to take place on the material. And in a shear fracture, either it may be in a tensile form or either it may be in a compression form. Compression form, due to that, fracture is going to take place in the material. And fatigue fracture, creep fracture, and cleavage fracture we will study. Fatigue fracture, it is going to happen, or it is going to take place because of the continuous cyclic loadings like compression loading, tensile loading, compression loading, tensile loading. Continuously alternative load is acting on the material. Due to that, material is going to get fracture, or we can say failure. And next, creep fracture. Due to the constant load and due to the constant load and at a higher temperature, the material is going to get fractured. And in a cleavage fracture, it is a brittle fracture. Due to the sudden load, the material is going to get fractured. These things we will study in our coming lectures deeply. So this is a brief discussion, or a brief information about the fracture. Now let us move on to the remaining portion. Now let us see the types of fracture. Fracture which is classified as three types. One is ductile fracture, second one is brittle fracture, and third one is shear fracture. This ductile fracture, we are also call it as a type 1 fracture. This brittle fracture, we are also call it as a type 2 fracture, and shear fracture, we are also calling it as a type 3 fracture. So in ductile fracture, any material any material in ductile fracture, any material, this is a material, this is a steel material, when it is under loading condition, when it is under loading condition, so some tensile load we are applying on the material. So due to that, what happens? Material start to deformation. Material start to deformation, or here, material starts to deformation. From the length is going to change from this to this. So in ductile fracture, I want to clear here, there is change in the length. It is what that is what that is a plastic deformation. That is plastic deformation is going to takes place in the ductile fracture. So before ductile fracture, it is giving a warning. It is giving a information. The material is going to get fracture, or we can say the material is going to get failure. So based on that required arrangements to be done, or the whatever the care has to be taken for to avoid the fracture. So that information we are going to get in the ductile fracture. But in the case of brittle fracture, what happens when any material, when any material, when any material, it is under loading condition. So it is under loading condition. When it is under loading condition, the metal or the material may get fracture without plastic deformation. It is a sudden failure of the material, or it is a sudden breakage of the material. It is not going to deform plastically. So that we are going to call it a brittle fracture. No plastic deformation, or very less plastic deformation in the fracture. In shear fracture, it is similar to uh, tensile fracture when the material is under tensile load, and the stress which is acting on the material at 45-degree grade, or inclination 45-degree, and due to that crack is going to formation at the 45-degree, or at the stress point. Due to that, the material gets fracture. So these are the three different types of fracture we are going to see in the failure of materials. So let us see the fracture with the help of some simple images. Here you can see the ductile fracture. As I said, in ductile fracture, it is plastically deforming. Means it is extending for some length, and then the fracture points will occur. So here you can see the cup, and here you can see the cup and cone arrangement in the material. It is a chromium material. You can see cup and cone shape on the material. And let us move some more images, or let us see the cup and cone fracture stages. So in any object or any material which is under a tensile load, here you can see, this is a tensile load. You just consider a steel material, and it is under a tensile load. So when we apply a load, and due to that load, what happens? Material, it starts to form a initial necking. Initially the metal will be in a regular form, or we can say it is a straight material. So when we apply a load, tensile load, a neck is going to form form here, and this is the first state, and we move on continuing the load. So what happens after certain time, small cavities are going to form at this location. Or small cavities are going to generate at the center of the material, and as the time moves, these cavities will join together or combine together and form a crack at this location, or crack at this point, that we will call it as a coalescence of cavities to form a crack. And in the next stage, or we can say crack propagation, that crack will extend, or the crack will extend up to the boundary of the material, up to the from this point to this point. So crack will propagate up to the boundary of the material, and as the load moves on continuously, at the final or at a certain stage, the material will get fracture. So that is what here you can see. Here you can see the cup and cone shape of the material. So these are the 5 steps we are going to see in a material, or we are going to see it in a when we apply a tensile load on a material. Let us see further here. When material is under tensile load, there we can see high ductile high ductile fracture high ductile fracture and moderate ductile fracture. The difference between high ductile fracture and moderate ductile fracture in the image itself, you can see. In high ductile fracture, the edge of the materials are very sharp or very deep. That type of fracture we will call it a highly ductile fracture. In moderate ductile fracture, the tip of the materials which are not sharp, we can say it is just a flat one compared to this highly ductile fracture. So that type of fracture we will call it as a moderate ductile fracture. Um, Here some more images you can see brittle fracture. Here important to notice one thing is, for brittle fracture, when two material gets separate, this area will always be, or almost it will be, flatter one. But in the case of ductile material, it is never going to flat. It is cup and cone or other shape is going to take place on the tip of the fracture. Even it is a same thing in case of a soft ductile materials and shear structure or shear fracture. So now let us move on to the next image. Same thing, the ductile and brittle fracture. In the brittle fracture, you can see flat, and it is cup and cone arrangement for ductile material, and this is for brittle material. This one is cup and cone surfaces for ductile materials. It is a more clear picture. This is a cone shape and this is a cup shape, and this one is this is for ductile material. This is for ductile material, and this is for brittle material. The surfaces of the brittle material is flat. So by studying these fracture surfaces, or by analyzing or by examining these surfaces, we can come to know what is the reason behind that fracture, or which kind of load has been applied, and what is the reason the material has failed. That can be examined the various methodologies or techniques, or even by doing some taking a photography, or even by using the SEM analysis that we will when we do a higher studies that we are going to learn. Here we don't have that. That is not available. That is not there for your syllabus. That part I am not going to cover here. So next, this is the important one: stress strain graph. So here is the stress line, and this is the strain. When the material is under when any material which takes sudden fracture, when any material which takes sudden fracture. So this is the graph you can see. So this is the fracture point. It means within the elastic limit, the material is going to get failure, or there is no plastic deformation. It is not giving any kind of information. A sudden fracture is going to take place in a brittle material. The example for brittle material is a ceramic material, we can say, or even cast iron is a brittle material. When it undergoes a load, we cannot analyze, or we cannot identify easily. Any moment the material may get fracture. That is what a brittle fracture. It means there is no plastic deformation in the brittle material. Now, ductile material. See, in the ductile material, this is the elastic region. Up to this is the elastic region. So after elastic region, it is giving information, or it is giving warning to the operator or anyone who is observing. So here the material is plastically deforming. It is elongating or extending for some time. So here it is giving clear information that the material is deforming. So this is the final state. At this point, the material will get fracture. So within this region, we can identify, or we can take a precaution so that we can avoid the fracture of the material. So somewhere we can avoid, or somewhere by stopping the load or reducing the load, with, at this stage, or at this stage, or at this stage, we can avoid in this way. By reducing the load in this way, we can avoid the fracture of the material. So even here you can see the energy absorption of the material. Energy absorption of the material in a brittle material. See the area. It is a fracture point. This is the fracture point of brittle material. The area of the energy absorbed. This is the area of the energy absorbed. This is the area of the energy absorbed. It is very less energy is absorbed by a brittle material before fracture. The same thing you can see, the area for a ductile metal is comparatively brittle metal, it is very large. See, this entire area is the energy absorption of the material before that fracture. So in most of the application, we always prefer a ductile fracture rather than brittle fracture. Why? Because ductile fracture, it is giving clear information that the metal is going to get failure after this stage. But in brittle fracture, it is not giving any hint or it is not giving any information. So it is somewhat not flexible to the any process or any operation. So hence we always prefer a ductile fracture. So with this, we are going to end today's session. Thank you.